at Euler's numbers, that's called E. Here's the question, what is E? Here we are going to see the application of E and also how to find the E value and stuff like that. Now let's look at the first one. Let's say we have logarithm of 5, log 5. And when we know that when we don't have anything given, base is always 10. So this is equal to logarithm base 10 5. The same goes to ln. Like whenever you have a ln and a value, there's e hidden, because ln is basically log e. Like this can be expanded as log e 5, right? So whenever we have a ln, there's always an e. And if you calculate e value, you can plug it in the calculator as well. If you find this one, you're going to get 2.718281828. So this is the e. E is basically a number. Now let's look at the interest rate equation. If you remember, amount is given by P, that is principal amount, times 1 plus R, that is rate, interest rate, and that one divided by number. This number is number of time interest rate is compounded per year, and then power n times t, number of time interest rate compounded per year times the year, that is time. So from this one we can calculate interest rate. For example, let's say our principal amount is $1, okay, $1, and the interest rate is 100%. R is equal to 100%, and let's say we want to calculate for 1 year. Let's look at some application. Okay, I'm going to go ahead and erase this one and continue here. So first, let's say the number of compounded times per year is 1. So what's going to be the amount? To do that, we can plug it in this equation. Like we put $1 and then n is equal to 1 here, and then what's going to be the final amount? That's what we are trying to find. To find that, we can plug it in the equation. Like we know that principal amount is 1, and we know 1, and then interest rate is 100%, and 100%, if you bring it into value, like if you express it in the equation, you have to divide by 100. When you do that, you get 1. If you get 50%, you have to divide by 100, that's 0.5, like that. So this is going to be 1 here, and then divided by number of times compounded in a year, that's 1, power n times t, n is 1, and then time is number of years is 1. We are just calculating for 1 year. So if you do that and calculate this value, you're going to get $2. You can try this, like 1 plus 1 over 1, that is 2. 1 plus 1 over 1 is 1, so 1 plus 1 is 2, and then 2 times 2 power 1 is 2, and then 2 times 1 also 2. So we're getting 2 right here. Now let's try this one. $1 is the principal amount, number of time compounded per year is 2, and then what's the final amount? Again, you can plug it in this equation. This is gonna be 1 times 1 plus 1 over n, power 1 times n. Here we know the n, that is 2, so 1 times 2 here as well. And if you calculate this one, you're gonna get 2.25. And you can calculate for number of time compounded per year 3, or let's try for, like, let's expand a little bit more. So if you plug it in the equation and calculate this one, you get 2.44. and if you plug 12, n is equal to 12, you will get amount to be $2.61. and if you put infinity, you're going to get value that is close to e, that is if you put n is equal to infinity, okay, this one's n. If you put n is equal to infinity, you will get a value that's close to e, that is like $2.71828. So from this one, you can see the equation of amount calculated using the interest rate is almost similar to the e equation. Like from that one you can also find the e value as well. So we can create an equation for e like this. I'm gonna express in a general form. Okay, so let's write the general form. The general form is going to be limit n approaches infinity. As the number become larger and larger and larger, 1 plus 1 over n reaches e. So we can say this one, but this is not the only way we can find e. There's multiple different way. Let's look at the second method. There's an equation to find out e, that is limit n is equal to 0, then limit n is equal to 0, then limit not equal to, actually approaches 0. When limit n approaches 0, one plus n power 1 over n, that also gives e. Now we can also try this one, like we can grab some random number close to 0, mean the number has to be small and it should be close to 0. Now let's try creating a table and finding those values. Okay, so here I'm gonna write the values. Let's try 0. Let's try 1 first. So here I'm gonna put n and then 1 plus n power 1 over n. So if I plug 1, that's gonna be 1 plus 1 power 1 over 1, and that's gonna give us 2. So that one is 2 here. Let's write it here. This is 2. Okay, what happens if I plug 0.1? 1 plus 0.1 power 1 over 0.1. If you calculate this one, you get 2.59774, 2.59774, something like that. So you can like keep on going. 774, like if you can apply 0.001, 0.00001. Let's try a very small number, because if we go closer and closer we get the accurate answer. So let's try this one. 1 times 10 to the power minus 6. That's like you're dividing a number 1 by million. So that gives 2.718 280469. So you can see as this function approaches 0, we are getting the e value, and from the e value, if you remember, e value is 2.718281828, and here you can see we are almost close to this one. But if you go a billion, 10 billion, this is gonna go closer and closer to e value. Okay, and there's another way you can find e value, that is by taking factorial. Let's look at that one. So here you can find the e value by getting factorial. If you take factorial, n is equal to 0 to infinity, 1 over n factorial is going to give you e value. To make this one, to try this one, what you can do is you can actually get a bunch of factorial 1 over n factorial and try that one out. So let's try something like, let's say, let's try up to 8 factorial. So if I do that, this is going to be 1 over 0th factorial first, then plus 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial, plus 1 over 4 factorial, plus 1 over 5 factorial, 1 over 6 factorial, 1 over 7 factorial, 1 over 8 factorial. So as you increase the sum of this factorial, it's going to go closer and closer to e. Now let's actually prove it. Okay, 1 over 0's factorial, that's 1 over 1. That's 1. We can directly write it. 1 over 1 factorial, that's also 1. 1 factorial is 1, so that's 1 over 1 also 1. 1 over 2 factorial. 2 factorial is 2 times 1, that's 1 over 2. And then 1 over 3 factorial, 3 times 2 times 1, that is 6. 1 over 4 factorial, 4 times 3 times 2 times 1. 4 times 3 is 12, 12 times 2, 24. 24 times 1, that is 24 as well. So 1 over 24. 1 over 5 factorial, 5 times 4 times 3 times 2 times 1. 5 times 4, 20. 20 times 3, 60. 60 times 2, 120. 120 times 1, that's 120. So 1 over 120 here. And 1 over 6 factorial, 6 times, 5 times, 4 times, 3 times, 2 times 1. So 6 times 5 is 30. 30 times 4 is 30 times 2 is 60. Okay, 120. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. 720 times 1 is 720. This is 1 over 720. And for the 7th factorial, you have to just multiply this number by 7. So 720 times 7 is what? 720 times 5 is 3600. Plus 1440. So if you add that, you're gonna get 5040. 1 over 5040 here. And 1 over 8 factorial, you have to multiply this one by 8. 5040 by 8. You're gonna get 40,320. Okay, if you add all of them, you are getting like 2.718, 827, 877. That is approximately equal to E values. Let's write the E value again. E values 2.718, 281828. Now here, if you look at this one, almost close, right? So as you increase the factorial, as you increase the sum of the factorial, if you add 1 over 9 factorial, 1 over 10 factorial, and if you go up to 20 factorial, you will see that it's getting closer and closer to E value. Okay, now let's look at the graph of e power x. Y is equal to e power x graph look like this. It goes like this. Okay, and from this, like in the e power x graph, if you draw a line like this, it's going to only touch one place at a time, and that's going to be the slope of the tangent. So y is equal to, we can say y is equal to, the height is going to be slope of the tangent, y is equal to m. And also you can actually find the area of this certain part of this graph by integrating. Like, let's look at the area equation. Area equation is given by integral a, this is a definite integral, in this one a to b, and then f of x dx, f of x dx. So area here for this function is given by integral negative infinity, because starting from negative infinity, the x is starting from negative infinity, so this negative infinity, and then x value, x reaching up to x, okay, dx. Then here we put e of x dx, e power x dx. Now let's do the integration. If you integrate, okay, let's do the integration. Definite integral going from negative infinity to x, and if you integrate e power x, that is still e power x, and then we have e power negative infinity. So e power x integral is e power x, and e power negative infinity, that is 0, because if you rearrange, so e power negative infinity is equivalent to 1 over e power infinity, and e power infinity is infinity, because we are powering a large number, so that's going to be an even larger number. So 1 over e power, 1 over e power infinity is equal to 1 over infinity, and 1 over infinity is 0 because we are dividing 1 by a very large number. So this is 0 right here. So we get 0 for this one. Therefore, the final answer is e power x. That's a relation in finding the area. And that's it for this video, guys. Thanks for watching. See you guys on my next video.